today's presentation is autonomous configuration with a short-range information sharing system, NAMI. This is the agenda. At first, I will introduce my research, then go to today's presentation. Because of COVID-19 pandemic, we have to have everything online. I thought this is the future style with IT technology, but unfortunately, we found a lot of things that cannot be done just with IT technology, because I have to make class from my home, but it's very difficult to have university class from my home. There is no reaction from students. It's very difficult. So I got an idea that we need IT technology and human ability. So this is our concept for IT technology and human ability. Just using both IT technology and human ability, we can expand our system. And at the same time, the IT technology part will be reduced by make use of human ability. Then the resources of IT technology, like CPU resource or network resource or other storage resource, will be reduced. This is a kind of sustainable system. So one application of our concept is called NAMI. NAMI is a messaging system. And I will explain the NAMI in the next slide. NAMI is a messaging system, but only between the people around you. NAMI use short-range wireless system like BLE, Bluetooth, and exchange message between the devices around you. Your message won't go to the internet, just exchange the people around you. So your message is not transferred to the other people, the other side of the earth, a very long distance. One application of NAMI is crowded close warning system for COVID-19. In the COVID-19, if people are very close to the, in a long time, it's very difficult to have some influence from the other people if they have COVID-19 virus. This is one application of our system. Another application is information sharing system for natural disaster. In the natural disaster, there is no internet connection because of very heavy damage in the internet infrastructure. But even at that time, the device can continue to communicate with each other, peer-to-peer communication. They can change, like they have some flooding or some bridges broken or other information. But the problem of this system is BLE is very slow, like under 2 megabit per second. This is a theoretical maximum speed. So usually we don't have such high speed, even in BLE 5, version 5. So as BLE is so slow, it is very difficult to send multimedia data. It's okay to send just a text message, but it's very difficult to send pictures or movies or other multimedia data. So how to transfer such multimedia data? We can use Wi-Fi. Using Wi-Fi, the Wi-Fi is faster than the BLE, so you can send photo or movie through Wi-Fi. This is the additional function for NAMI, but this is a system to use Wi-Fi, and the lowest layer is device. This is a smartphone using communication through BLE. On that devices, there are 3 layers: cloud and agent devices. But actually, edge servers is moving. This is not a fixed edge servers. They are moving like devices and have some access point, Wi-Fi access point. So as these edge servers is moving, we don't have any fixed information for the edge servers. There will be different mobile edge servers. Also, device is moving. So we need to configure such information dynamically. And so doing so, system must detect edge servers and configure automatically. It means an install application or connect Wi-Fi access point automatically. So how to detect the moving edge servers? This is a general technology to find other nodes. There's a couple of types of network. When you use mobile ad hoc network, they use OSPA protocol. OSPA protocol is each device send hello message periodically. Then other nodes, when they receive this hello message, then other node reply with hello message. Then they can find, they can detect other nodes around you. But this OSPA protocol is very low-level implementation. So on the like iPhone or mobile device, we don't have OSPA protocol for now. Like BLE or Wi-Fi, in the BLE, there are 2 types of device: periodicals, peripheral and central. Usually, peripheral device send advertise packet, then central device receives that packet, then reply to that packet. Then peripheral and central can communicate, and so on. In the Wi-Fi case, usually access point send beacon message. When device receives the beacon message, then they try to connect to access point. You need an SSID and password in the Wi-Fi case. So in the NAMI, we cannot implement OSPF protocol. And when we want to use Wi-Fi, we need SSID and password, but edge is moving. There's no fixed SSID or password. So they have no method to know the SSID or password. But in the NAMI, we use BLE, already using BLE for communication. So in our system, we can share the SSID and password through BLE. So we implemented NAMI's function on edge servers. So when edge server has such function, edge server can connect to the device using BLE. Then they can send SSID and the password to the device. Then device can connect to the access point. Then start communicate through Wi-Fi. And also, we need dynamic configuration. I mean, the devices are moving, the edge servers are moving. That means we cannot communicate every time. Not the communication doesn't exist forever. So sometimes there's no servers, there's no connection, or there's no access point, or other than that. Even such cases where the system have to continue their functions. So when there are some errors, we try to connect or resend the photos or other informations. We list up all the error cases in this figure, like there's no edge servers or there's no communication between cloud other than that. So in every cases, we have a system to reconnect and resend the request to the other side. This is one example. If there's no edge server here, they try to reconnect when the edge server is available. We implement plot time using devices iPhone, it is a MacBook. Wi-Fi access point is in this picture, like very portable travel router, and cloud is a Linux server in some data center. This is a normal case. Upper device send a picture, then there's no error, so they can send picture to the cloud. Then the downside is the other device, they can receive the picture from cloud. This is the normal case, there's no errors. This is one example of there's an error in edge servers. The first time, because there's no edge servers, they cannot send photo to the cloud, but that request is added to the task list. So when each server can connect to the device, then we send the photo to the cloud. After that, the other side of the device can receive the photo from cloud. We implement all the cases. Okay, in this presentation, I explained how to handle multimedia data on NAMI with Wi-Fi and the automatic configuration using BLE and Wi-Fi. We implemented on experimental system and show that everything goes well in our experimental system. Oh, this is feature in Japan. That in some place there was a very heavy earthquakes in January, like this picture, but at the same place in this September, there's a heavy rain at the same place. They had two consecutive natural disasters. So in that disaster, they don't have any internet connection, or there's no electric power or something like that. There's no water or there's no food. So we want to expand our system for that kind of accident, even if there's no internet connection, our system can help them to communicate where they are living, what they want, water or food or something like that. We want to expand our system for such kind of natural disaster. Okay, thank you very much.